All right, sharing my screen here. Hope everyone is able to see my screen right now. It's a presentation right now. So today in our Clarity Track session, we are going to talk about the fungible tokens. We've had a look in the previous sessions, how to build an NFT contract, and we looked at the SIP-009 trade associated with it. So similarly, we also have first-class citizens in Clarity, which are fungible tokens, and they conform to a trait which is SIP-10. And moving forward today, as a part of our session today, we will be taking a look at that trait. We will be taking a look at how we implement the SIP-10 trait and build a fungible token. So we will take a look at the functions that we can have for a fungible token. And then we will start with an example of a decentralized exchange for a fungible token. And we will continue with that tomorrow as well. But we will be able to take a look at what we are building. So the first portion that we will cover is the SIP-10, the fungible token standard that we have. Now, again, the core devs in Clarity, they ratified on this SIP to identify what all minimum requirements are to conform to be a fungible token on Stack's network. So this is equivalent to ERC-20 token. And you would see if you compare these two tokens, the ERC-20 and SIP-010 token, you would see a similarity between these functions as well. So starting with the first element, you are defining a trait. This is the way you define a trait, and I am naming it as SIP-10 FT trait, and then I am exposing a few function signatures, which will be the interface to this token. You will see that there are 7 functions here. And out of these, there is only one public function, which is transfer, and the others are all read-only functions. Now I'll start with the read-only functions, get name. So you will also see that these functions are different from the NFT. You remember there are 4 functions in NFTs. We have 7 here, and they have different requirement to be a fungible token. So to briefly, quickly give an idea exactly what this fungible token is, you've come across Bitcoins and you have come across stacks. So if you trade one Bitcoin for another, you end up with the same Bitcoin again, meaning that there is no uniqueness to that token. You are just exchanging the same Bitcoin for another Bitcoin. So this is what is the fundamental difference between an NFT and NFT. So non-fungible tokens are unique in their own way, and fungible tokens are not unique, but they are currencies which you can use and trade and build decentralized finance and exchanges. So the function get name, it's a read-only function, and it returns the name of the token. Pretty straightforward. You need a name for your token. Then you have get symbol. This is, again, a read-only function which returns the ticker symbol. So you might have a short abbreviated ticker symbol for your token. So for Stacks, in case of Stacks token, SDACKS is the name of the token, but the symbol is STX. So that is how you have a symbol for your token. Then we have get decimals. There are no decimals in Clarity. To be able to work with a decimal system, the token, the fungible token, needs to define if there are any decimals. So if you consider the stacks token, the decimal system there is unsigned integer 6. So it means that whenever you are working with the stacks price per se in your code implementation, it would mean that 1 million makes one token. So you work with microstacks in your code when you are doing all the math, etc. And that 1 million is what makes 1 million microstacks is what makes one stacks token. So if when you create your own token, you want to think about if there is a need for you to have a decimal system, and if you would want a smaller unit to comprise your token. Then we have get balance. This read-only function returns the token balance for a provided principal. So if you will see that you are providing an argument principal, so you can get the balance of that token for that principal that you have passed. And it would return the response in an unsigned integer amount, balance amount of that principal. Then we have get total supply. This returns what is the current total supply of the token, because I could mint 1,000 stacks, and then there could be different users buying minting different amounts of stacks on chain. So it would be good to have a supply which is telling us a function which is telling us what is the total supply current for that token. So that is what is get total supply. Then you have get token URI. This is very similar to the token URI that we saw in the NFT portion, which resolves to a metadata file for that token. And then that metadata could contain a bunch of information about your fungible token. So if you will take a look at the response for the token URI, it is an optional. There might be a URI for your token, there might not be. If you have some metadata built out for the token, you could have that and host it on some server, which would simply be a JSON format. This metadata response is in JSON format, and it is supposed to comply to a new SIP that is being ratified to identify what the metadata for a fungible token could look like, similar to the way we have a SIP-16 for the non-fungible token metadata standard. Now, the final function that we have in our trait is the transfer function. This is, again, as the name suggests, we are transferring a certain amount of our token from the sender to another receiver. Now, there is also a possibility to have a memo attached to this transfer, and therefore we have an extra argument here. Why do I say extra? Because we saw that transfer function in NFT is the NFT ID from the sender to the principal, but they do not have this optional buff in that list of arguments. So this memo is this is basically an optional memo if you want to provide a memo along with your transfer. So this should be an optional one. You could send some memo, you could attach some memo. Okay, we will dive into the implementation of this standard, but other than that, we will be talking and building a decentralized exchange. So we are going to build a marketplace. Now, though I'm saying that we will build, but it's a big code. So probably I will go through the logic and different implementations to consider while building a marketplace for fungible tokens. Now we are building a marketplace where the users can swap. For the use case, I am fixing that our swaps are working only with the stacks token. So that means I can swap another fungible token like Mega with stacks and vice versa. I could swap a Miami coin with, for stacks and vice versa, etc. So I'm fixing one token variable at this end, that the exchange is always happening against stacks or with stacks only. A real decentralized exchange would not be limited to stacks swap only. It would be between different fungible tokens. But for easier understanding of this DEX, I am fixing this stacks token for the swap. And I could talk a little more about how what all extra functionalities will go in to have a pair of fungible tokens to allow that exchange. Now, during this implementation, we will kind of touch these terminologies that we come across in a DeFi world. We will talk about liquidity. We will take a look at what the exchange rate is, why is it important. There is a fees associated, and then the main functions, which would be the swap functions, where the users can come in, they can swap their stacks to buy a new token, or they could swap a token that they have to get stacks in return. So this is what the general idea is of the DEX. Now I will dive into the fungible token back to SIP-10 trait and see how we implement the fungible token if you want to build a fungible token for your project or use case and how it works. I'm going to start a new shared here real quick. Okay, I hope you're able to see the VS Code right now.
Yep, looks good.
All right. Okay. So here, it's a very straightforward copy and paste of the existing SIP-10 trait, and I've just pasted that here. The name might be different. I have named it as FT trait. The contract that it lies in is traits, and I have created a folder which is external, which contains the traits and a bunch of other fungible tokens. Now, when I get to traits, it's simply the transfer function and all the other read-only functions. Now, once I have defined a trait, I need to conform it when I implement this. So I have created a bunch of other fungible tokens. I'm going to go with the Austin token and start from there. So first of all, I am implementing, we have already worked through this before, how to implement the trait. So I'm implementing a trait which is in my project folder. So I am doing a dot relative value to the contract dot traits, and then the name of the trait. And what name do I have? That is the FT trait. Now, the Austin, to be able to start with the implementation of a token, the first thing that you need to define is that there is a token, and then you need to define what that token is. So the first thing that you might want to do is define what your token is. So in that sense, I am saying that I need to define fungible token. Now, this is a Clarity built-in function, which is taking care of building a fungible token for you and then taking care of all the other elements like minting and transferring and ownership, all of that in the background. So this is the way that you define your fungible token. So you will see that I have already built out the contract so that I could go through all of the functions and also not delay in starting the DEX implementation. So once you have defined it, now we will go to defining every function that is present in the FT trait, starting with the read-only functions. I am going to come here. So the first read-only function, let me open the trait here. Okay. So get name, it does not take any input parameters. And then we have a response. The response is expected to be a string if it is successful. Otherwise, unsigned integer if it is an error. I don't think that we will fall into the category or a situation of getting an error in our implementation. And we are going to simply define what is our token name. So once you have decided what your token looks like and what the name is, you can put it here, get name, and you can just simply define what your name is. This would also mean that your name is not changing in future. But if you think, I don't think that you should be changing the name in future. But if you think that there is a use case that it might change, then you might want to store this on chain, have another public function which could set a new name to your token, if that is what you want. So get name is returning me the name of my token. Next is get symbol. This is the ticker symbol again. So I am mentioning that my Austin token ticker symbol is ATX. If you think that it is going to change, again, I don't think that it should be changed. But if your case is such, you could set a new symbol at a later point. So no input arguments, just a simple response in string value. Next is the decimals. Again, no arguments here. It is expecting an unsigned integer, and this means that I am expecting a number here, which tells me the decimal place. So as this comment mentions that the number of decimals used, example, 6 would mean that 1 million represents one token. So if I'm mentioning 0, and then I tend to use prices in such a way that I'm working with prices and transferring amounts, then that transfers that will take place for my token that would mean that whatever transfer amount I'm taking, it is equivalent to a single straight token. If I say that my decimal is U1, this would basically mean that my token ATX has, let's call it micro Austin, and 10 micro Austin would be 1 Austin token. So this is the representation and the use of decimals. Just because we don't have decimals in Clarity, we tend to utilize the decimal system this way so that we can perform and find results which are in decimals. So say that you want to transfer 10.10 Austin. You can't do it this way. You will have to multiply. You will need to have some logic which will multiply it with 10 to identify what or exactly what is the micro Austin that we are working with. So decimal system is important, and you will come across with different scenarios to use. So for now, I am going with decimal system 0. Stacks token by default, it is 6. The next function is the get balance function, which says that I will be able to get the balance for a particular principal, the amount of tokens that this principal holds. Now, the way we have seen different built-in Clarity functions available with us for the NFT tokens. Similarly, we have functions for the fungible tokens as well. So we don't need to really take care of maintaining the balances and total supply and stuff like that. We only need to make calls to these functions, and Clarity in the background, just because tokens in Clarity are first-class citizens, we don't need to maintain a lot of stuff there. Clarity language does that for you. The only thing that I'm doing here is making a call to FT get balance. This is the Clarity inbuilt function, and it takes 2 arguments, which is the token that we are talking about and the principal for which we need to find the balance for. So this is basically saying, get me the balance of this user holding Austin token. Now, this Austin token, if you remember, is the one which we declared here, which is the fungible token. Pretty straightforward to get a balance. And there is also another function, which is the get total supply. Now, we don't need to find the supply for any principal or anything. We are just trying to find the total supply available for this token. And again, we have the built-in function called ft get supply. And we give it the argument of the token that we are looking for. So you gave Austin to it, it would print out the current latest total supply of Austin token. And then we have the token URI. Now, token URI is something that I'm fetching it from on-chain through a data variable. This is why, because I feel that at my starting point, I don't have a token URI, but if I tend to have a token URI in the future, I should be able to set a new token URI here. And that is why I'm exposing a public function, which is set token URI. This is not from the trait. This is a function which I am additionally adding so that I can set the URI on my asset on my token. So this was all about the token read-only functions. Now, this is the first public function that we talked about. Then we have a transfer function. Before I go to transfer function, you would always want to be able to mint new tokens. I have written a function which is mint, where the users can come in and call this mint function along with the amount that they want to mint and the recipient to which it would go. Now, I have, though I mentioned users here, I want to say that I restricted my token to be minted only by the code deployer. Probably that is because I want to use that use case. It could be, the token could be exposed in such a way that you, as a user, you are directly minting it and doing a transaction sender, but that is not what I'm doing here. I am saying that only the code deployer for now is able to mint new tokens. And then once there is someone holding those tokens, they can make a transfer to send it to another principal. So looking at the mint function is again pretty straightforward. It is saying there is a clarity built-in function which is called ft-mint. You make a call to ft-mint to your token and then the amount that you want to mint and the recipient you want to mint it towards. So what I'm saying is here, the scenario is that there is a contract deployer. Let's say I deployed a token, and if somebody wants to mint it, I am the one who is going to take their principal and make these mint calls. Now, that might not be a very nice solution because I am minting the amount of my token for a single recipient here. What if I was to mint for a list of principals? So now again, these are the public functions that I'm writing and exposing so that we can make use of the token and mint it. But remember that these functions are extra functions. These are not present in our trait. Why? Because these can be implemented in very different ways, and we want to keep it on the use case and the project case, how somebody would want to mint tokens. So this is a straightforward mint function for minting it to a single recipient. There is also a custom function that I wrote to send, calling it send many, where I can get a list of recipients, a maximum of 200 at the time. And then I am saying that I can send it to a principal, and this is the amount that I need to send it to this principal. Hopefully this is making a little sense. Now I will not dive into the logic that I wrote here, but in a very straightforward sense, I am using the fold function, which is a way for me to iterate over this list, and whatever amount I want to send to this principal, I can do that by mapping to every element and then sending the token to different recipients. Whenever you have a chance, I will post this code to GitHub, to Clarity Camp, and I will want you to take a look at these functions, because sometimes you will, If in clarity, we do not have infinite loops, and in that case, we want to utilize the functions of fold and map to achieve some level of repeatability and not writing the same line again and again. If as a dev, I come in and I know there is no iteration allowed in clarity for unlimited amounts, then what I would probably do is start with begin. And then I would basically do element at, I'm looking at recipients, and then index U0 and do something about it. And then I would do the same thing for U1. And then I would do the same thing for U2. So instead of writing that 200 times, what I'm doing is I'm doing a shortcut, which is a way to iterate over the list so that we can send so that we can mint not only one recipient and amount at a time, but we can send tokens to multiple recipients at the same time without writing 200 lines of code. I'm using this fold and map functions. You will have to take a look at the check error function, and then you have to take a look at the send token function. So these are all the extra functions that I wrote, which you might not even need, but I am putting it out there so that you can refer to it if you come to a scenario where you are making use of the mint many, send many, transfer many functions sort of. Now, lastly, we come to, so we have minted some tokens. So there are users who hold tokens, and now as a token holder, I could also be applicable to transfer those tokens from myself to another. And that is why we always have the transfer function, which is a part of the trait. And we always need to declare this, define and provide the implementation for the transfer function. So here is that first validation that the transaction sender and the from is the same. So I'm making sure that the transfer that I am making and sending this from should be same. Then if it is all good, well and good, otherwise you are not authorized. So I'm throwing an error that you are not authorized to make this transfer. Now you will, I'm not fully sure, but you might have seen a memo associated with transfers. And therefore, the transfer has this memo optional buffer available. So if you do not have any memo associated, so whenever you make the transfer call, you will have to send none to it. And that is why the buffer is optional here, so that we can transfer none to it. Now, if there is some sort of memo, you will then have to send it wrapped with a sum value, and it would be some buffer associated when you make this transfer call. And this, I think this buffer is there because we don't know how long a memo would be. And therefore we are encrypting the message, the memo there, and then sending it to the transfer function. So if there is a memo associated, we are currently only printing. So there will be an event that will trigger, which will print the memo value. Other than that, we are not doing anything else. If there is no memo, it is none. If there is a memo, I am printing it and not really utilizing this for now. But when a transaction happens and there is a memo associated, so when you go to Stacks Explorer, you would be able to see that event there and a memo associated. I also feel with Clarity 2, I think I took a look at the new functions exposed. There will be a new stacks transfer function with along with the memo, so that you don't have to explicitly print it, but it will take care of what to do with the memo. And the actual expression is this FT transfer function. Again, this is the built-in function available in Clarity so that we can transfer the token from the sender to the receiver. And what are we transferring? We are transferring the token that we are talking about, Austin token. The amount is taken, the sender and the receiver. And this would transfer the token from one user to another. So these are all the functions that are available in our fungible token. Now, as I mentioned, they are not just limited to this 7 functions that we have in the trade, but we can write as many functions as we want, which are applicable to our use case, depending on your project. You might not need send many, you might not need a mint. You would need a mint, but you might not do the mint this way. You could do it another way. So yeah, I think this is it for what to do to implement a fungible token. So at this point, we have the trait and we have a fungible token ready. Similarly to Austin, I created sample other tokens as well, very similar to it. The only change that I made is that I'm naming it a different name to the token. And Mega is again the same. Everything is the same, only my token name is changing, or, you know, what would change is the get name, get symbol. It could have different decimals and it could have different token URI. So this is a typical way to implement your fungible token. Before I dive into the next portion of DEX, I would only be able to introduce DEX today. But I would be, I can take a few questions if you have any around the fungible token implementation.
Well, I was just wondering when you would actually use, what would you, do you ever implement this in your code, or are you always using an already existing created fungible token like a city coin or something?
That's a great question. I created my own function, my own token. You are wondering if I am using a city coin function?
Well, no, I was looking at it, I was trying to think, well, you know, implementing this trait in Clarity is pretty straightforward, but to actually have a functioning cryptocurrency, you have to have, you know, mining operations, stacking operations, etc. Or at least that's what Citycoins does. But I guess I was thinking, is there some, like, you're using this as a container somehow, but not needing all that back end off-chain functionality, like some sort of container?
So yeah, so thinking about the stacking and mining and DeFi and DEX, now these are all different use cases that could apply to fungible tokens. I would not be able to take all of them, but one example that I'm going to take is the DEX and showcase how a utility is associated with a token. But if you want, tomorrow I can go through the existing Citicoins protocols, because just because Citicoins decided to take up, bring their own token, that is, that there is different utilities around there. I do believe that they are available to stack and stake, and they expose those functionalities via a client application so that you can mint and you can mine all of that through their UI. But I will not.
They have quite a bit of other additional they have additional traits that you have to, their core and their city. But
Correct.
Again, if you didn't do all that and you were just doing code, is there some reason that you would create in your code an SIP-10 for a container or some functionality that never intended to create an actual mined and stacked cryptocurrency?
Let me clarify on the question. Are you saying that is it necessary, or is there a need to implement a token if there is no need?
Is there, if you're not intending to create, say, a Citicoin or a new cryptocurrency, do you use this trait implementation for any type of object or container in your code?
Probably not. No. So when I am implementing this token, I am thinking as a project use case where I'm building my own Citicoin or Miami coin, something like that, or, you know, Alex token or Arcadico token. Now, this is only a glimpse of a standard token, how you would start the implementation. But when I come to, let's say, building a decentralized exchange, or I'm using DeFi, I would directly use the tokens and get the users involved to start using my application. And I wouldn't need to build these tokens at all. Does that?
I guess I just need to hear your additional lecturing to probably sink in. Maybe there's something. It's next
Okay.
thing.
So okay, to recap a little. So what I'm trying to do here is that if you decide upon an idea where you would need a fungible token, even if you are building a DeFi protocol, you would need to build your own token. It could be a liquidity pool token. It could be a cryptocurrency token. But if that is not your use case, well and good, you don't need to create any of these tokens, and you need not implement any of this stuff at all. You don't even need this trait here. You don't need these tokens here. If you are making a project which is related to a marketplace where fungible tokens are involved, for example, one utility, then that marketplace would utilize existing tokens meaning stacks, Citicoins, zero token, or megapond tokens, things like that. So there are two scenarios. One is that you are not writing these tokens at all, but you are creating a DEX, but utilizing existing tokens. And second scenario is that you are building your own cryptocurrency with the utility. And that is when your trait and implementation of the token would come into existence. Now, the DEX example that I took, that I was about to start with, this is taking stacks into consideration. If you think about this. Stacks is not the token that I created here. I just created a random Austin token, and I'm putting Austin token to my exchange. So now this is not what I want. I could directly go with the city coins. This is not the way you write it, but I could utilize a city coin and make my DEX here. And further down the road, I wouldn't even need to specify which token you are exchanging here. I would have to pass it from a front end to say which exchange is happening between which token and which token. So in short, from what until now, what I've understood from your question, you don't need to create these tokens or write an implementation for a token if you are dealing with a use case where you are using existing tokens. You would just need to bring those tokens into your contract if you are using them directly, else you wouldn't need that as well. For example, in a DEX case, we know that it's an automated market maker where any token can come into existence in the exchange and then can be exchanged for any other token if the exchange for that pair exists. Now I think I went too off topic, and too farther ahead. But I will take a few steps back and get back to the DEX requirement that we are building here. So, okay. Now, what is a decentralized exchange? Decentralized exchange is basically a marketplace where users can come in and they can exchange tokens for other tokens. Now, how it's like how the old finance, the traditional finance works, especially in our stock exchange, that you are buying some stocks and shares for a certain amount of fiat currency. That is what we are trying to replicate here. I will not be able to show an automated market maker functionality and implementation, but I will try to give as much idea as possible as a use case so that we can make use of existing tokens and create an independent platform for DEX, and where my DEX should be able to transfer between different tokens. So if I want to buy 5 Austin tokens for 10 stacks, I should be able to do that. If I want to buy 5 Austin tokens for something, some 10 stacks worth, then I should be able to do that without the intervention or a centralized party involved. So it's an exchange without anybody else being involved, and it's going to be a very simple exchange. And again, though I'm using the word automated market maker, this is the implementation that we discussed would not be able to fully showcase that. But let me switch my share screen here and give you an example what we are trying to achieve. Okay, so this is what we are trying to achieve. What we will do is we will try to understand why do we need liquidity. Now, I'm not a financial person. I have very limited knowledge there with, especially with terminology, but I'll try to make it as simple as possible. So there are going to be terms, and those terms are liquidity, exchange rate. There will be a fee associated when you are doing those swaps, and then the actual swaps. Now, the use case that we are building is only limited to swapping a stacks to another fungible token and swapping the fungible token that you hold in return of stacks. So I can give my stacks and get a new token. I can give any other fungible token and get stacks for in return. Now I shall start with one second. Stack swap. So we met with stack swap the other day in Meet the Team session. So that this is the functionality that we will try to reproduce and see what all will be needed to kind of replicate this. I'm not saying that I'll be able to replicate the whole thing, but I'll give you an idea what all takes to think about a utility and then implement and use those fungible tokens. The utility here is straightforward, that there are a bunch of fungible tokens available. And let's say that I have stacks with me and I am willing to give my stacks so that I can get Miami coin. And just because I want to use this Miami coin somewhere, I want to either stack it somewhere, I want to exchange a Miami coin for something else. So my use case is that I have stacks, I want Miami coin in return, and then later on, I want to use Miami coin somewhere. And for that to be available, we need a swap mechanism. We need a decentralized exchange because we don't want to depend on the centralized financial exchange. So the first thing that you will see is that you will be, as a user, I will be able to mention that I'm ready to swap like 10 stacks. And it is telling me, it is calculating on a run at runtime how much Miami coin I will get. And it is also telling me that the current exchange rate is 1 stacks to 682 Miami coin. So tomorrow, when we start, we will take a look at what this exchange rate is and how is this being built in our Clarity code. And today, maybe I am able to get 6,801 point something MIA for 10 stacks. Tomorrow, it might be different. I might get a lesser amount or a greater amount. And that completely depends upon the liquidity that we have in the contract. So I mentioned a few things from what we'll do tomorrow. One is the swaps that will happen. So the swaps that happen between stacks and Miami coin, or Miami coin back to stacks, I can do either way. I can do 6,000 Miami coin, and then I will be able to swap that back to stacks and get 8 stacks in return. There are mathematics involved in maintaining the liquidity and also identifying the exchange rate. So I will touch base a little maths tomorrow on how this liquidity is maintained and how the prices change, and how today I'm getting 8 stacks for MIA, but tomorrow I might get 7 or I might get 10. So hopefully it will make much better sense tomorrow. But again, just because I implemented the token today doesn't mean that you need a token. I believe that if we are only talking about a simple stack swap implementation, I won't need any tokens for the stack swap platform. I am dealing with Mia, which is already created, Stacks, which is already there. So these tokens are already available. As a user, I can come in and I can swap between these two tokens. And I am not building my own platform like the stack swap platform token. But now, when stack swap came in, they did mention that they have their own token, and that is the stack swap token. And they also have their liquidity pool token. So tomorrow we will not be building a stack swap token, but we will very similar take a look at the liquidity pool token that will be created. So this is a starting point to a decentralized financial swap, which we used to see in a decentralized stock exchange. We are kind of going to replicate that here and see what all goes into that. You might already have much more experience with the financial exchanges and how the automated the AMMs work, but I will try to understand that a little bit more on my end as well, and come back to you tomorrow to share some of that knowledge and how you convert that domain functional knowledge of exchanges in a decentralized way. So for today, I think that is it from my end. I was hoping to get into a little more coding, but I haven't. So tomorrow, let's see how much we are able to cover. And Philip, I see you have another question saying, are we using Oracle? No, we will not be touching on Oracles from a DEX point of view, but I did do some research on Oracles, and I know that Kay and other people have a bunch of questions on what Oracle is, etc., etc. I'll come to that Oracle portion in just a bit. Kay, your question, how much FT Mint costs us to call? So how we define the base price of the token we just created? Interesting question. I have no idea. I do think that the price of a token is variable, of course, but you might before your launch, this price might depend on the number of users who are ready to invest in this token. So I am thinking that there is some portion where liquidity matters. So the number of investors who are ready to buy this and liquidity. So maybe that is a starting point to identify what is the starting base price for that token. And then it eventually it fluctuates depending on the market. Okay, so the Oracle, I will just take a minute there to give you a direction. Now, when I was reading about oracles, I read that Redstone Oracle works in a different way. There is a concept called meta transaction pattern. And apparently, when I think when I don't want to say things that I don't fully understand, but I do want to say that there is a concept of meta transactions, which means that rather than the contract making a call to the external API, what the meta transaction proposes is that you verify the signature of the data that you are sending. And that is what the Redstone API connector is doing in Stacks. I was reading a bunch of articles. I think this one is one of the other elements. One second. So the main Redstone article that I read Redstone Stacks. Yeah, this one. So this is the only article that we have on Stacks to Redstone integration. And it mentions that Stacks application will be able to pair smart contracts with real world data, including price information, and support price feeds over different assets. But Redstone works a bit differently from other oracles. Often, Oracle protocols store the data on-chain, meaning the transaction fees and transaction speed can hamper the Oracle usability. So instead, what Redstone does is it uses the meta transaction pattern and only verifies the information integrity on-chain. So on-chain, there are no API external calls made to verify or fetch the data or fetch the latest current market prices, etc. But what happens is that you are just verifying the signature on-chain, but your information is still off-chain. So how I read a little more documentation on that. I'm not sure if it's still making sense, but what I'm understanding is that a client application would be the one which is making a call to Redstone, fetching the market prices from there, and then sending that data to our Clarity contract. And Clarity contract would only verify that signature and verify the integrity of the integrity of the data that has been sent to the contract. This is the only research that I have done till now to understand what is happening. So that is when I came across the meta transaction pattern. I haven't given a lot more read there, but that is one concept that I have come across in terms of what is happening, in Redstone and Clarity integration. Kay, you have a question further on that?
Yeah, that meta transfer thing, I figured it out how it works actually. The reason they do it, it's like digital signatures of your PGP, since the
Correct.
data is outside the chain, and then you need to rely third-party point, and then chain has the public key, and then the Redstone sends data encrypted with the private key, and you actually check it inside the chain and make sure the caller function is actually Redstone, not like a guy like Philip Kelsey. You know what I mean? I just tease with you.
Correct.
So only thing I couldn't figure out, still I couldn't figure out. You said client calls the Redstone. That part, it's big question mark. Everyone actually wrote their receiver functions, and then that receiver function has a buffer. Buffer has the encrypted key, and then they call the Redstone contract, and the Redstone contract has a private key, public key inside it, and then they actually do the math and then verify that key coming to buffer. and then you said, okay, this data definitely came from Anashka. I know that you are you. You know what I mean? But still, nobody actually mentioned about how we, as a contract, I just wrote a small contract, the counter contract. And when I reach the counter 5, I need to do API call and then get the name of the 5 in English, like 5. Yeah, that part is still missing. Nobody actually covers that part. I understand now. I think these old oracles are working one way, not 2 ways. So there's no like a request response. You go to Oracle and then you actually set it up your, and also data, you cannot access any data. They actually collects data behalf of you, like all financial data. If you go to Redstone, they are talking about like hundreds different data sources. So, and then you say like, send me this data portion to my contract, maybe every hour or something. It actually calls your contract, that function, every hour with the updated the value. I think the Oracle went like that.
Yeah.
Yeah, at the beginning, I completely misunderstood this Oracle like a API gateway client request response pattern or kind of, but it's not, I believe.
Right. It's like a middleware which comes in between our Clarity backend and probably the front end. So Redstone acts as a middleware, which is providing you with the data, and then Clarity verifies the signature and says, yes, okay, good. And whatever functionality has to happen, happens.
But how does it, like, Chainlink does the request. Your Chainlink, you create a request ID, then all the nodes, query that request ID.
Chainlink is a different story. Chainlink is actually another blockchain, and they have their own smart contracts within their blockchain. So you write your own Chainlink smart contract to create a request. That was the missing.
I guess what I was trying to think. Kay, how do you do this? So it's like, if you call, what I'm hearing when I've read, how do you handle? I mean, I can send a conversion rate to my smart contract, from Python or JavaScript every 10 minutes. How do you, or every hour or whatever? How do you handle a mempool? I mean, you're not, the other nodes aren't going to know what that conversion rate is, right? Until it's committed to the blockchain. Isn't that correct?
Yeah, it is. Yes, you're right. Actually,
so that's the problem I run into. It's like, well, if you send off a conversion rate, and then it's like, what if you're in the middle of a transaction and you tell someone's trying to close a transaction, and then the rate changes in the interim, but you didn't have that request ID to Chainlink, so the information's stale,
Well, think about real life. If I agree on something right now, at that moment, we handshake. Like you say, I'm going to pay you $10 and you're going to give me 5 stacks. And then we agree on it, right? And then, but I couldn't send the money yet. And then I'm going to put it in a USPS envelope. But by the time I put it, the price change. But still, our agreement is true because we agree on it on that price. Doesn't matter. We should change the thing. So by the time,
but these are convergency risk. These are currency or conversion risks, currency conversion risks. These aren't recon transactions. These happen in micro split second times. If you have a tick on a conversion rate and it lasts 10 minutes, that could be a huge amount of money.
That part I don't know. This is like a finance question, I guess. It's I start learning the technology behind the oracles. I mean, there's not big deal. There are pull, push, pull up, and then the chain base. But I don't know the financial part. I don't know how who utilizes data, and I don't know how yet.
Yeah, that's interesting that you're spearheading that. Kind of interesting how it turns out. The Chainlink, they sponsor those transactions, and every node is guaranteed to get, is the way I understand it, an updated, up-to-date conversion rate, where the market you're wearing. But Redstone, it kind of interesting. If you have to wait 10 minutes to get the conversion rate, that could be
But
material.
the chain link guarantees in their chain, not outside their chain. The same thing happens, if you chain link connected to Slack chain, you will not get the up-to-date version of it.
Well,
Don't forget.
well,
chain
I guess
link-
I'm not entirely sure. I know all the nodes get the same version, but I don't think you have to wait, 5 minutes, 10 minutes for the next Bitcoin block to take place to be able to read your conversion rate that you save to I guess an on-chain variable contract. Again, that creates some problematic exercise to stop your transaction, make sure that it's kind of, it'd be kind of interesting how anyways, just I guess it's this topic of discussion.
Agree. Let's end this session. Thank you for the session, by the way. Anashka and Sierra, she's here, right? And see you guys tomorrow.
Thanks, Kay. This was an interesting discussion. I don't have all the answers. From a clarity point of view, I can still
There are different implementations. Of course, there's no one answer. Every
Right.
third-party company implements the other way. I can come up a new version now tomorrow, like Philip said. I can write a JavaScript, Node.js script that calls one function, pay me or charge me like 1 point to update that value. I don't know. Just like everyone's doing different way.
Yes.
There's no one way. I agree with you. That's why nobody has like a solid understanding or answer for it. Anyway,
Correct.
see you tomorrow.
Thank you, everyone. See you tomorrow.